Welcome to Your Math Explained, where we make math simple and clear. My name is Angela, and in this video, we'll dive into what that log button on your calculator is and what it does in math. So let's get started with the definition of a logarithm. So here we have log base a of b is equal to c. So the a here is the base. So you read this as log base a of b. And this can always be rewritten as an exponential equation. So we have this is the same as a to the power of c is equal to b. But we do have a couple of restrictions on a, and that is a has to be greater than 0, and a can't be equal to 1. So how do we actually use this? Well, if we're asked to evaluate log base 3 of 9, the answer might not be obvious because we're not used to seeing logs yet. So we can use this definition here and convert it to an exponential equation. And all we have to do is match up the letters in this definition to make sense of the equation. So let's go ahead and give that a try. So we would have log base 3 of 9 is equal to c, and c is what we're trying to find. So now using the definition, we have our a is equal to 3, so we would have 3 to the power of c is equal to b, which is 9. And now this is much easier for us to find the value because we're used to seeing exponential equations. We know that 3 to the power of 2 is equal to 9. So therefore, our c is equal to 2. And similarly, to evaluate log base 3 of 81, we would write log base 3 of 81 is equal to c. Perform the same conversion, so we would have 3 to the power of c is equal to 81. And now we know that 3 to the power of 4 is equal to 81, so therefore c is equal to 4. So one small note is that sometimes you might not see a base. And when you don't see a base, it is assumed to be 10. So meaning if a is equal to 10, then we don't need to actually write the base a. We just write it as log x. So as an example, we're asked to evaluate the log of 1000. So you don't see a base here, which means that it is actually log base 10. So again, using the definition, we will write this as 10 to the power of c is equal to 1000, which means c is equal to 3. For our next question, suppose we have a function f of x and it's equal to 2 to the power of x. We want to find the inverse function. So to do that, we're going to set f of x equal to y. And then we're going to swap our x and y. So we start with y is equal to 2 to the power of x. We're going to perform our swap. So then we get x is equal to 2 to the power of y. And now we're going to use the definition from above to convert this into a log equation. So this would give us log base 2 of x is equal to y. And the last step is to replace y with the f inverse of x. So our inverse function is going to be log base 2 of x. So we can see that log base 2 of x and 2 to the power of x are actually inverses of each other. And similarly, if our base was 10, then 10 to the power of x and log x would have the same relationship. So this paves the way for us to easily graph the base log function, and we are going to be doing that next. So here, we want to sketch the function f of x, which is 2 to the power of x, and the inverse function, which is log base 2 of x. So let's start by drawing the exponential function f of x. So 2 to the power of x, we can plot a couple of points. 2 to the power of 0 is going to be 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And then 2 to the power of negative 1 is 1/2. So that tells us our function f of x will look like this. So here, this is our f of x is equal to 2 to the power of x. So now, our f inverse of x is just swapping the x and y values, which means we're going to have our point 1, 0, 2, 1, 4, 2, and 1/2, negative 1. So that means our f inverse of x is going to look something like this. So this is f inverse of x is equal to log base 2 of x. So let's go ahead and write down some properties of this log function. Let's start with domain. We can see that our domain is x is greater than 0 because we cannot log a negative number. And then our range is y is an element of all real numbers. And our x-intercept is at x is equal to 1. Our y-intercept, we actually don't have any, because as you can see, when we get closer and closer to x is equal to 0, our graph is going towards negative infinity. But we never actually cross the y-axis. So therefore, our asymptote is going to be x is equal to 0. So we have a vertical asymptote. And this makes sense because when we were talking about exponential functions before, we had a horizontal asymptote at y is equal to 0. So now let's do a quick recap of everything we covered in this video. We went over the definition of a log and how logs and exponentials are related. So they're inverses of each other. We learned how to graph a basic log function by swapping the x and y value of an exponential function. And then we learned how to use the definition of a log. So now it is your turn to give this a try. Now that you know what the graph of log base 2 of x looks like, can you sketch the graph of this transformed function over here? And once you've done that, let us know in the comments what the x-intercept will be. And you can always check your graph using Desmos to make sure you've graphed it correctly. That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.